So we are going to look into the basic concepts of momentum and also the laws and theorems related to momentum. So first of all, momentum is a vector quantity which is usually denoted by P. So henceforth, to represent momentum, we can write simply P, and above that we will write down one arrow. So momentum of any object is defined as mass of the object times velocity with which it is moving. So that means we can write mv, where v is velocity. As we have seen, it is a vector quantity.
Yeah.
Okay. What is the direction of this momentum? Can you tell me?
Same direction of velocity.
Yes. So it will have same direction as that of the velocity. Direction as that of velocity. Okay. Now, momentum is also known as mass in motion because every moving object will have this characteristic property. Every moving mass, every moving mass has this characteristic property. So, characteristic property. Now, it usually resembles inertia, but obviously it is not inertia. Inertia has no formula, inertia has no such factors. We don't know what are the complete factors on which inertia depends. Inertia is the property of the object due to which it resists any change in its state of rest or of uniform motion. But again, inertia does not have any formula. So instead of inertia, to represent the force or to represent the moving mass, we use the quantity called momentum. Okay. Now, what are the different laws or theorem which includes momentum? So one of the important law is Newton's second law. Newton's second law. So Newton's second law says that
Force
net
equals rate of change in momentum.
net force is equal to rate of change of momentum. So obviously rate of change of momentum means final momentum minus initial momentum divided by the time duration in which this momentum change has taken place. Okay. Now, whenever we have to calculate or whenever we need to calculate the change in momentum, always assign a direction to a particular, always assign a sign to particular direction. For example, if the question says that there is a car and if this car moves in straight line with some speed, let's say it is moving with 20 meter per second, and within let's say 10 seconds, within 10 seconds this car speed becomes 25 meter per second within 10 seconds. Now if the mass of the car is 1000 kg, then what is the force of the engine? What is the net force acting on the car? So here we have to assign the direction. So what we can do is, let us take right side direction as positive. So we can write initial momentum is equal to mass into initial velocity, and final momentum vector is equal to mass times final velocity vector. So our net force will become Pf minus Pi by delta T. Putting the values, m v minus u by delta T. So can you tell me what is the answer you are getting?
Oh yeah, that's technically mass into acceleration.
Perfect. So how much you are getting?
Well, if it, yeah, the change in velocity is fine. Yeah, the acceleration is 0.5 meters per second square.
Acceleration is 0.5 meter per second square, then multiplied by mass.
Yeah, then
How
that's
much?
500 kg meters per second.
No, 500 kg meter per second square, which is known as Newton.
Oh, yeah, that's right. Oh, yeah, Newton.
Okay. Now
500
there,
meters.
yes, there is something that you should know, that people do write that net force is equal to m into acceleration, but this is a special scenario. So what is the general scenario? General scenario is, we know that net force is equal to delta P by delta T. That's okay. Then you write down delta MB. That's also okay. And here comes, you have to do like this. We take mass as outside and we will write down delta V by delta T. Then you write down plus, and you write down velocity vector outside and then do delta M by delta T. This is the actual formula or actual expression for net force acting on any object which is moving with certain velocity. Now, if the body is a rigid body, or if the body is not changing with time, if the body's mass is not changing with time, the body is rigid body, then delta M by delta T will be zero. That will give us net force is equal to mass times delta V by delta T. Now, this is equal to mass times acceleration. So it means that when we write F is equal to m into A, that we have to write when mass is not changing. If mass is variable, if mass also changes with time, then this is the formula that we have to write. Okay, and if mass remains constant, if it is not changing with time, then directly we can write F is equal to m into A. Is it clear?
Yeah, very clear.
Okay. Now, as I have told you that we have to assign the direction, that is important. So based on that, let us do one question. So there is one object of mass, let's say 2 kg. It is thrown horizontally towards a vertical wall at a speed of 40 meter per second. Now it hits the wall and it bounces back with the same speed. Given this, find the change in momentum. Find the change in momentum. Yeah, try to do it. Okay, 160 kg meter per second. How you are getting 160? It is
Oh,
bouncing with the same speed. Yeah, tell me.
oh, yeah, 40, then, yeah, 40 to the right, and then it is minus 4. 40, so like 40 minus 40, that is going in the opposite direction because it's a vector quantity. So it's equal to 8.
Perfect. So basically what
And then
happened
8
that,
to
yes, and then 80 times mass will be 160. But here you have to, okay, what is the direction of change in momentum, towards right side or towards left side? Because change in momentum is also a vector quantity. So towards right side or left side, what you will write? Okay, let me explain. Whenever you do this type of question, first you assign the positive or negative to any direction. So let's say if anything is going towards right side, let it be positive. So it means that we can write initial momentum pi, initial momentum vector, as 2 times 40, that is 80 kg meter per second. This will be plus because initial velocity is toward right hand side, it is going towards right. Now final momentum, since the body has bounced back and it is moving towards left hand side after hitting the wall, so final momentum will be minus 2 times 40, because now we have to take this direction, which is, as per our sign convention, we have to take negative. So it is coming to be minus 80 kg meter per second. Now you find out the change in momentum. Since change in momentum is always equal to final momentum minus initial momentum, so this will be minus 80 minus 80, so minus 160 kg meter per second. This negative sign says that change in momentum, this vector is towards left hand side, and that is the final velocity direction for the object. So answer is change in momentum is 160 kg meter per second towards left. Is it
Left,
okay?
yeah.
Yes. So this is the basic concept about the momentum. Then now we will do some problem practice after this.